Now we have question number 7. Question number 7. An airplane passenger carries a 215 Newton suitcase up the stairs, a displacement of 4.20 meter vertically and 4.60 meter horizontally. A. How much work does the passenger do on the suitcase? So we need to find the work does the passenger do on the suitcase. Our law is W equal to F d cosine theta. Now here we have the force and the displacement in the same direction. So the angle will be 0 and cosine 0 will equal to 1. So our law will be W equal to F d. W equal to F, we have it in the question, which is 215 multiplied by the displacement, which is equal to 4.20. Here in the question, I used 4.20 vertically because the passenger will raise the suitcase up. So I should use the displacement vertically, not the horizontally. So the final result for the work that equal to 903 joule. This is the final result for the work. B. The same passenger carries the same suitcase back down the same set of stairs. How much work does the passenger do on the suitcase to carry it down the stairs? So here we have the same suitcase, so that means the same force, but in another direction. So the final result for B will be exactly the same magnitude as A, but in different, in opposite direction. So here for B, W will equal to minus 900.3 joule. This is the result for B. Now about question number 8. In question number 8 is exactly the same way. Here we have the displacement and also we have the force, and here we have the angle. So by using the same law, which is W equal to F d cosine theta, we can find the work. So it's exactly the same for the previous questions. Here we have another practice problems. Now we have question number 10. A catamaran with a mass of 5.44 times 10 to power 3 kilogram is moving at 12 knots. How much work is required to increase the speed to 16 knots? And here we have a note with, that tell me 1 knot that's equal to 0.51 meter per second. So I need to find the work by, I will use the law, which is W equal to half mv final square minus half mv initial square. But now in the question, I don't have the velocity, the final velocity or the first velocity. So I will use the note here. He told me that one note equal to 0.51. So V initial will equal to 12 multiplied by 0.51, and that's equal to 6.12 meter per second. And for V final, we have a 16 nodes, so 16 multiplied by 0.51, that will equal to 8 point, sorry, 8.16 meter per second. Now I have V initial and V final, so I can find the work that's equal to half the mass we have it in the question, which is 5.44 times 10 to power 3 multiplied by V final. V final, we found it, which is 8.16 square minus half 5.44 times 10 to power 3 multiplied by V initial, which is 6.12. Sorry, here we have 6.12 square. Here we have square. So the final result, by using the calculator, the final result, it should be 8 times 10 to power 4 joule. This is the final result for question number 10. Now we have question number 11. A 52 kilogram skater moves at 2.5 meter per second and stops over a distance of 24 meter. Find the skater's initial kinetic energy. How much of her kinetic energy is transformed into other forms of energy by friction as she stops? And how much work must she do to speed up to 2.5 meter per second again? So in the beginning, we should find the skater's initial kinetic energy. The law of the kinetic energy, which is Ke, that equal to half m v square. Because we need to find initial, so it's v initial square. Now Ke equal to half of the mass we have it in the question, which is 52 kilogram, multiplied by V initial. V initial square, we have V initial, which is 2.5 square. So kinetic energy by divided by 2, this is will be 1, and this is 26. So kinetic energy will equal to 26 multiplied by 2.6 square, 2.5 square. That will equal to 6.25. And the final result for kinetic energy will be 162.5 joule. This is the kinetic energy initial. Now we want to find how much work must she do to speed up to 2.5 meter per second again. Now we have another law. For the second part of the question, we will say that W equal to half mv final square minus half of v initial square. So because here we have speed up to 2.5, so that means this is the final velocity, and the first velocity it will be 0 because we have a stop. So W equal to half m mass, that's equal to 52, multiplied by velocity square, which is 2.5 square minus, now here we have half m v initial square, because we have v initial square that's equal to 0, so this is will all equal to 0, and w also will equal to 162.5 joule. Exactly the same for the first part of the question. This is for question number 11. Now for question number 12. In question number 12, we have also mass and velocity initial and the final velocity. We need to find initial and final kinetic energies. So we should find it exactly the same for question number 11 by using the law of kinetic energy, which is Ke equal to half of mv square. It depends on the question, which is v initial or v final. So I will not solve it because we already solved exactly the same one as 11. Now we have example problem number 3 about power. So an electric motor lifts an elevator 9 meter in 15 seconds by exerting an upward force of 1.20 times 10 to power 4 Newton. What power does the motor produce in kilowatt? In the beginning, we will write the noun and the unknown. So from the question, we have d, which is equal to 9 meter, 9 meters, and also we have the time, which is equal to 15 seconds, and also we have a force, which is equal to 1.20 times 10 to power 4 Newton. And we need to calculate the power in the question by kilowatt unit. So we have our law, which is P equal to W over T, the work divided by the time. So the work is equal to F multiplied by D over T. Now we will write the numbers. F, we have it in the question, which is 1.20 times 10 to power 4, multiplied by D, which is equal to 9, divided by 15 seconds. The final result should be 7.20 kilowatt. This is for example number 3 in the book. Now about the practice problems in the book, it's exactly the same for the example. For question number 14, for example, here we have the force and we have d, and also we have the time. So by using the same law, which is P equal to W over T, we can find the power. Here also we have in the question number 15, also we have the distance here and the time and the force, and by using the same law we can also find the power. So all the questions will be in the same way, except this question. This question, an electric motor develops. Here we have 65 kilowatt of power as it lifts a loaded elevator 17.5 meter in 35 seconds. How much force does the motor exert? So for question number 17, uh, we have our law, which is P equal to W over T. So P equal to W, that's equal to F d, force multiplied by the distance, divided by the time. So we need to find F, how much force does the motor exert. So we need to find F. That means F will equal to, here we will write D, and here we have P multiplied with T. So F, the force, equal to P, we have it in the question, the power we have it, which is equal to 65, multiplied by the time. The time we have it, which is 35, over D, which is the distance, that's equal to 17.5. So the force will equal to 130 Newton. This is for question number 17. Now we reach to the end of the questions. We have just question number 18, which is the challenge. This is a homework for you, so please solve it and send it to me. Here also we have some questions. This is a quiz for you. So also I needed to solve it and send it to me. The first question is, by the way, this is the questions is about the whole lesson. So question number 1, when is work done on a system? We have here 4 answers. So please find the answer, the correct one. This is question number 1. And for question number 2, why would a star do no work on a planet that travels in uniform circular motion around it? This is question number 2. Which one is the right one from here? Question number 3. What is the ability of an object to produce a change in itself or the world around it? Which one is the correct one? Question number 4, which describes the process of doing work? And the final question is, which is the rate at which energy is transformed? This is the questions for you about the whole lesson. Please solve it. And also we have a challenge, which is question number 18. I need you to solve it and send it to me. Until here, we reach to the end of our lesson. See you soon in another one, inshallah.